all. We are still in the Solow model, but this time we try to incorporate technological progress. Okay, so we still the textbook is the same by Sorensen and Rita Jacobson, introducing advanced macroeconomics. Okay, so we have the here. All right. Now, so the previous Solow model, the basic one, despite its elegant representation of economic dynamics and its interesting implications concerning the structural characteristics that determine an economist's level of economic development in the long run, the previous Solow model, in its basic form, cannot account for some important style aspects regarding the process of growth. Yeah. So, in particular, it cannot support an equilibrium in which capital per person, output per person, and the wages grow at positive rates in the long run. Okay, so this is the weakness of the existing, sort of growth model that we have learned. Now here, at a stable steady-state equilibrium, we already know that Kt plus 1 must be equal to Kt, and we represent it by K hat. So the growth rate of for capital per person will be, in expression 1 here. Okay, so at the steady state, growth rate is like this. Also recall that output per person, okay, is actually A Kt alpha, which is at the steady state y hat equal to A K hat, isn't it? So this is expression 2. Okay, now, and also we can have wage rate per person given by expression 3. At the steady state, we just change the, notation here to hat. So we have 3. Now, from 2 and 3, from 2, recall back 2 is this, okay, output. We can have economic growth that looks like this. Okay, so if you minus 1, then you get some rate here. Okay, and at the steady state level, okay, the growth rate is 0. Why? Because if I recall back the writing, so we have Kt here, and then have Kt plus 1 here, and then we have 45-degree line. So if you have the curve like this, so this is a steady state, okay, and you start here. So when you go here, the process from K naught to K hat, in between there's an economic growth, positive, but it decreases until you reach at the steady state here, okay, at point A, for instance, then the growth stops increasing, isn't it? So that's why at K hat, the growth is, 0. The growth of output is 0, and also the growth rate of wage per person is also 0 as well. Now, how all of this could happen? There must be some economic intuition behind it. To see why this happens, so we need to use transition equation from the basic Solow model and write it in terms of growth rate of capital per person. Okay, so this is what I mean. Yeah, so if you can recall back, okay, so Kt plus 1 over Kt minus 1 is actually equivalent to, okay, if you do it properly, as A Kt alpha minus 1 minus n plus delta, okay, so 1 plus n. Okay, all right. Now, you see here on the right hand side, we have two terms. Let me change the color of the pen. So this is the first term, and this is the second term. Okay, so if we look at the first term here, the first term on the numerator here, this one, yeah, the first one, okay, expresses the marginal contribution of what? Of the current capital stock on investment expenditures. And this term is actually decreasing in the stock of capital per person as a result of diminishing return. Diminishing return here, the share of capital is less than 1, so that's why we know it is diminishing returns. And look at the second term here, this is the second term, n plus delta. And if you can recall back, is the growth rate of, population of worker or people, and delta is basically the rate of depreciation. So the second term on numerator here, which is this, okay, is the new capital stock that needs to be created through investment just to keep the stock of capital per person constant at its current level, okay. So as a result of diminishing returns, it is impossible for stock of capital per person to grow at positive rates forever, okay. So that's why you can see from the graph here, it grows like this, but then the growth is decreasing until you reach at the steady state where the growth becomes zero. At some point, the return to investment will become sufficiently low, just enough to create the capital goods necessary to keep the stock of capital per person constant. Now, this is the steady state at which the growth rate is zero. Like I said just now, yeah, any further increase of the stock of capital per worker above this level is not possible at all. The return to investment is just too low for this to happen. And so the preceding analysis suggests that by eliminating this tendency for diminishing returns, we can modify the model so that it becomes closer to what the stylus facts of economic growth seem to suggest. So our purpose in this part, in this part of subject, is to undertake such a modification to the basic Solow model. So that's why we want to introduce technology in a Solow model so that we want to have, persistent growth rather than zero growth once we reach steady state. So that means if we have persistent growth, so yt plus 1 over yt minus 1 has to be greater than 0. When it has to be greater than 0, there's a possibility that we don't reach at this level of steady state though, because we want to have, growth forever. If you have steady state at one point, okay, then the growth will be 0, isn't it? So once we want to have this growth forever, then we are not reaching steady state, but we keep growing. Okay, so how to do this is by one example or one possible suggestion is by introducing technological progress in the Solow model. To introduce technology in Solow model, and when I introduce technology in Solow model, so technology now becomes endogenous. If you look at the previous, introduction of Solow growth model from the previous lecture, video, you can see that there is technology there, and the term technology is given by, these terms, okay, A. And A here is exogenous because A doesn't depend on any other variable or economic, variables in the, output function itself. So now we want to have a new aspect in equation 4. We want to have, we want to make it, technology explicit as seen by, by us. So the new aspect in equation 4 is the presence of the term HT. Now what is HT? It is labor augmenting technological progress. So basically it's a measure of labor's efficiency or productivity, because we want to measure how productive is a labor in terms of raw labor, in terms of times and or effort be transformed into output itself. So if we have HTLT here, it is actually effective labor. So what we all have all this while is just labor. But once we have HTLT, it's called effective labor. Okay. So to assist us in the analysis at a later point, when it comes to model solutions, we need to define certain things here. So what are those things? So these are the things. Okay, we need to define number 5 and number 6. So number 5 is, capital per effective labor. Last time we have this, recall back, last time we have this, small letter kt is equivalent to kt over lt, isn't it? This is capital per worker, okay, capital per labor. However, because we attach technology to the labor itself, which is ht, so when kt divided by htlt, it becomes k tilde here, and this k tilde is basically capital per effective labor, not just per labor, or per effective worker, not just per worker. Okay. Similarly, when we talk about y tilde here, this is output per effective labor. Okay. So how to get this? So we have kt equivalent to, capital KT over LT. In order to derive k tilde, okay, so we have k tilde here is equivalent to this. Then what about this? This is actually kt over LT, isn't it? That's why we just replace it by this and then over HT. So similar to 6, yeah? So this is what I said just now. So using 5 and 6, we can verify that, output per worker, if we write it in the form of output per effective worker or per effective labor, we can write it this way from here. Okay. But what about wage per worker and interest rate per worker? So can you find it yourself? Do the work step by step like this until you reach this point. Don't just exchange it to, let's say, WT to WT tilde. That does not help you in study. You must do it step by step like this. Okay. So next, we have the main assumption. Okay. So we have the main assumption about the variable HT that it grows over time at a constant rate of G. The growth rate is G and G is positive. So formally, okay, we have HT plus 1, HT in the next year is equivalent to 1 plus G, the growth rate of HT times HT itself. So if you modify it, you can have something like this, isn't it? HT plus 1 over HT, you can have 1 plus G, isn't it? And you can have HT plus 1 over HT minus 1, you can have growth rate equivalent to G, and then this is positive based on assumption here. Okay, so other than that, we have, the additional assumption underlying equation 10 here. Yeah? We have additional assumptions. Okay, and then the rest we have the assumption that we used from the basic Solow model that we have learned earlier. So for instance, 11, this one I'm sure you know what it is. 12, I'm sure you know what it is. And 13, I'm sure you know what it is. Also, we have investment in period T used to add to the capital stock available for future production. Yeah, so we have something similar like before, where the future capital stock is actually depending on the investment today and also the existing capital stock today. So there's correction here. Yeah? This one shouldn't be KT plus 1. This one should be KT. 1 minus delta KT. Okay, now how to derive the economic dynamics or how to derive the first order difference equation and how does it look like? So you derive as usual, but and then you can get this. So try to do it like the way we derive first order difference in the previous basic Solow model. Now, once we have this first order difference, we want to check whether we have long run steady state or not. Okay, and if we have, how many of it? Now, the long run equilibrium is a solution for which we have in 16. There's a correction here, yeah. So this one should be KT plus 1 tilde equals to KT equals to K hat. Okay, so how to obtain the equilibrium of steady state here? Okay, now in order to obtain this, okay, what you need to do is that usually we have two steady state. The first one is, let's say, call it K star equal to 0. That means Y star is also equal to 0. Okay, and this is the first one. The second one here, all right, K double star equals to what? In order for you to find it, then you have to make sure that this one is K hat, change it to K small letter K hat, change this one to small letter K hat as well, change this one to small letter K hat as well. Okay, and then you rearrange 15 so that K hat, only K hat on the left side, and then the rest on the right hand side. Then you can have the answer for the positive, steady state, which is K double star. Okay, so in this case, actually, this one should be star, double star, instead of K hat. Okay, so try to do this and I can give you the solution, but you have to find out how to reach to this solution. So you have SA divided by delta plus N plus 1, okay, plus G 1 plus N, okay, and then in bracket 1 over 1 minus alpha. And then from here, you can find what is the steady state output per effective worker. Okay, so the process is the same like the way we find steady state in the previous, video. Okay, but this time it is called output per effective worker or labor, capital per effective worker or labor, and then you can check the stability of this steady state and this steady state. Okay, now when it comes to graph here, okay, so we have the transitional dynamics and long run growth. Yeah, so here kt plus 1, here kt, and then you have 45-degree line, isn't it? So try to check. Yeah, so at this 45-degree line, kt plus 1 tilde equal to kt tilde. Okay, now if you try to draw based on this, first order difference equation, yeah, you check what happens to f0, you check what happens to f prime kt, is it positive, negative, okay, and then you check what happens to f prime at 0, you check what happens to f prime is kt is, infinity increases largely, okay, then you can see that this one I won't show you, okay, but you have to do it on your own. Also, you also need to check the second derivative, yeah? Is it less or greater than 0? Now, once you check all of this, you're going to get something like this as well. Okay, so this is f kt tilde. Okay, so at this point, call it point A, then you can have k double star, small letter, yeah? Okay. So this one is K, small letter k, capital effective, per effective worker at the steady state. This is another steady state. K hat equal to 0. And then this steady state is actually the one that I show you just now. Okay, delta plus n plus g1 plus n. Okay, close. And then we have this 1 over 1 alpha. Okay, so here try to check whether steady state here is stable or not. Try to check whether steady state here is stable or not. There's a formal way, mathematical way to check it. Okay, now, so recall that the steady state is expressed in terms of the stock of capital per effective labor, yeah? We want to know what happens in terms of capital per person or capital per worker. So the long-term implications are quite different compared to the basic Solow model that we have seen in the earlier video. Why? Because this time we have per effective labor in our equation. So to see this, we need to do something, yeah? So how do we do it? So recall back, all of these equations are given to us, and then recall back, and the steady state condition requires us to have kt plus 1 tilde equals to kt tilde. Okay, using 5, we call back the 5 here. Here is 5. Okay, we have 5 here and 6. You use 5 first because we want to solve for this actually. So we know that at the steady state, kt plus 1 tilde equals to kt tilde, and using 5, okay, we can have, okay, kt plus 1 over ht plus 1. That's why we have kt tilde, isn't it? And then we have equals to kt over ht, isn't it? So this is actually this is actually this from 5, isn't it? Then what we need to do is that cross multiply this, yeah? Then I bring the work here, okay? Cross multiply this, and then use 10, okay? Where is 10? This is 10. ht plus 1 equals to 1 plus ght. So we need to use 10. Cross multiply first and then use 10. So when you cross multiply, you have something like this. kt plus 1 over kt, small letter, yeah? And then you have ht plus 1 over ht. Okay, and then we know that this one is actually equivalent to 1 plus g, isn't it? Given by 10. Okay, then from here, you can come up with this. Okay, rearrange it, you can come up with this. Okay, So similarly for this, we know that initially yt plus 1 tilde equal to yt tilde when it is at steady state. Output per effective worker or labor or person, okay, must be equal to output per effective labor for current year, yeah. And using 6, this one is actually looks like this, isn't it? So yt plus 1 over ht plus 1 equals to yt small letter, yeah, ht, okay. And then we cross multiply this. So we cross multiply and then we use equation 10. Then we can get something like this. Yt plus 1 over yt, yeah, equals to ht plus 1 over ht, yeah, equals to 1 plus g. And then you rearrange, you can get something like this. Of course, when it comes to stock of capital per effective worker or labor, we can have steady state. But because our interest here is more on capital per worker, output per worker instead, then we rearrange it. Then we found that, okay, over time, capital per worker grows at the rate of G. Output per worker grows at the rate of G as well. Can you see? When we allow technological advancement in our model, we can have economic growth for capital per worker, economic growth for output per worker. But of course, like I said, capital per effective worker, stock of capital per effective worker, we can have steady state instead of growth. Okay, same goes to output per worker. Okay, but what about the growth rate of wage rate, WT? Yeah, how do we do it? Now, let's see, I erase this so that I can have some space to show you. Okay, so here we know that, recall back, yeah, you have something like this. So we have wage rate per worker is actually given by this, isn't it? 1 minus alpha, A small letter kt alpha, okay? And if we relate it with, ht here, then we can have something like this, ht plus 1, 1 minus alpha, yeah? Sorry, it's not ht plus 1. This one should be this. But now we want to know about the growth rate of wage rate, WT. So how do we do it? Okay, so we have WT plus 1 over WT, yeah? So this is small letter, all of them small letter. And we know that we can write WT plus 1 as this, 1 minus alpha, okay? A kt plus 1 alpha in it. And then ht plus 1, 1 minus alpha in it. Okay. Now, next, WT is given by this, so we put it here. So, 1 minus alpha, AKT, okay, alpha, HT 1 minus alpha. So, cancel, and if you try to cancel off all of them, but actually, before we cancel it, yeah, it's not about cancel, sorry. So, here, let me do this. Okay, so here what we can do is that you can have, okay, let me use right pen. You can have the first term here after the equal sign, this one, this is what I mean. And then you can have the second term here, isn't it? Okay. So basically it becomes this. Okay. So yeah, after that we cancel, we are left with this. Kt plus 1 over kt, then you have to the power of alpha, okay, this is simple maths, ht plus 1 over ht, and then we can have 1 minus alpha, isn't it? Okay, and for simplification, okay, this one is actually, let me write the answer here. I continue the answer here because I don't have enough space. So it becomes like this. Okay. So it becomes something like this. We bring it here. So we know that this one, the one inside here, the ratio of kt plus 1 over kt is actually 1 plus g. All right. To the power of alpha. Also the same for ht plus 1 over ht to the power of 1 minus alpha, 1 plus g, 1 minus alpha. So when you simplify, okay, that becomes what? 1 plus g. Now, 1 plus g is basically, okay, wt plus 1 over wt. But if you want to have growth, which is g, you just rearrange it, that you can have something like this. Okay, then you can have something like this. Then we can rewrite it something like this. So wt plus 1 over wt minus 1. We bring 1 to the left hand side, and we are left with g on the right hand side. So that is the growth rate of wage rate wt. Okay. So now in the model, the addition of a process that improves labor productivity basically has major equilibrium effects here. So we can see now the model can account for stylized facts, okay, relevant to the idea that many of economists have been able to sustain positive growth rates in the long run. As you can see, the growth rate in the long run is G, isn't it? As we saw in the finding here. Okay. Now, so it is similar to the data, the empirical data, where we have growth rate of capital per person, okay, and growth rate output per person, and the wage are the same, okay. Now, so we can say that the model now can account for stylized facts relevant to the vast majority of Western economies, in which Western economies has persistent and a very long, constant growth rate G, okay. And not only that, okay, the model is able to capture the stylized fact that real wages on average grow at the same rate as output per worker as well, isn't it? Can you see growth rate of real wage and growth rate of the output are the same, and that is G, okay. So it can also account for the stylized fact that requires interest rate to be roughly constant in it. So how this can be derived? This one you have to further the study and extend the study more. Now, despite its ability to generate outcomes that are supported by the empirical facts, the model itself possesses serious disadvantages or shortcoming. So specifically, the model fails in providing us a clear understanding of the structural characteristics that support higher economic growth. And instead, the economic grows at the rate of G, okay, at the rate of G here, for which we know nothing. Okay, there is nothing in the model that indicates the underlying fundamentals or principles that affect the process of growth. Yeah, we don't even know. We know that it keeps growing. So let's say, so we have KT here, and then we have KT plus 1, and then we have 45-degree line here. So the curve maybe looks like this. It doesn't, converge to the 45-degree line. If it converges to the 45-degree line, that means it has steady state. But in this case, we have G for KT plus 1 and KT. I'm not talking about the KT tilde, because if it is KT tilde, we are talking about, capital per effective labor. Now we are talking about capital per labor, wage rate per labor, and whatnot. Okay. Now, so this is therefore, okay, the growth rate that we have here is therefore just an exogenously given parameter. So yeah, it is given 1 plus G. We just assume that HT plus 1 over HT and some other things is equivalent to 1 plus G in it. Okay, so this is just an exogenously given parameter. So because of this, economists refer to this framework as what? As an exogenous growth model. Okay, this is what we call exogenous growth model. Okay, so because if it is exogenously given, such a framework is not very helpful for policymakers who wants to implement policies that aim at increasing the economic rate of growth. Yeah. Why? Because if it is exogenously given, then we don't know what drives it, and then because we know it can drive economic growth, but we don't know what can drive it. What kind of policy is suitable for G? Okay. So for this to be possible, then we need frameworks that can pinpoint those characteristics, either economic or structural or institutional, that can support even increasing levels of GDP per capita. So we want to modify this model in such a way that will allow us to identify and understand the forces that can affect an economy's rate of growth. Okay, so with such information available, then only policymakers can devise appropriate policies that may eventually lead to higher growth rates. Yeah. So when we talk about endogenous growth rate, this is an alternative for exogenous growth rate. Yeah, because we want to solve this problem. Because initially G is given, then it is not possible for us to come up with policy that can affect G because we don't know what's the determinant that can affect G in this model. So we have to endogenize it. So we have what we call endogenous growth theory. So if we have endogenous growth models or theory, so we can basically answer certain questions here. So these are the questions. What are the fundamentals under which an economy may achieve higher growth? Okay. What are the explanatory factors on why some countries have persistently higher growth rates compared to others like the US, UK, and Canada? Also, what types of economic policy may be successful at increasing the growth rate of output? So if we want to adopt economic policy, we may want to say that growth rate G here is a factor of something else. Let's say money supply or whatever. This is what it means by endogenizing, economic growth. Yeah. So we will turn our attention to construction, solution analysis, and discussion of endogenous growth model, but not in the next lecture. Yeah, this one is just my note for my typical PowerPoint slide. This one you have study in further details when you go for master degree. For PhD degree. So this is all about the Solow growth model for your level. Okay. Now, there are a lot of things that we can use in this endogenous and also exogenous growth theory. We can have human capital, not only labor capital. Yeah, we can have human capital. We can have knowledge. We can have health, status capital, and whatnot. So this kind of model is very rich actually. So that's why if you read, economic journal articles, especially theoretical papers, then you can see a lot of this being used in their paper to endogenize economic growth so that they can study the determinants of economic growth that can lead to different types of economic growth as desired by policymakers.